Thank you, Ben, by the way. I appreciate this. I love presenting to different crowds, especially across the United States. Um, and this is definitely my topic. This is near and dear to my heart, is hybrid cloud and multi-cloud. And so I created this slide deck for a specific customer a while ago, and since then it's gone through a few iterations. And most of the deck is handmade by me, so you can see very almost corny graphics being used because I'm not one to fluff something up, right? I'm here to really show some just solid details. And so I'm going to open up with, the thing that everybody should already be aware of, right? VMs are all about software-defined data center. And our cloud foundation is really compute, storage, and networking. It's vSphere, vSAN, and NSX at its core. And we've been writing on this for a while now. And, of course, Amazon came to us a few years ago and said, hey, we'd like to run some version of VMware in our environment. And we said, okay, great, we're the partner for that. And we basically call this Cloud Foundations. Now, you can run this on-prem and you can automate it with SDDC Manager, basically giving you a full-blown operating cloud on-prem. And when we partnered with other cloud providers, we also came up with the VCPP program for managed service providers. So you've probably heard of like Rackspace, Main 365, and some other major cloud providers. Well, they run pretty much the same thing that you can run on-prem if you were to do VCF. And of course, we have our obvious partnership with VMware Cloud, VMC on AWS. This one's actually owned and operated by VMware. So there's a distinct difference on that one versus like the VCPP. We actually own, operate, and support. So when you contact support for VMC on AWS, it's VMware people you're talking to. Now, Azure has a partnership with us as well. It's ran and operated and supported by Microsoft directly. It's also known as AVS, and it's actually a very good offering. It's the same platform, right? vSphere, vSAN, NSX. And so, I'm not going to really, there's really no need to fluff it up because it operates nearly identically as the other clouds do. We also have a partnership with Google for Google Cloud VMware Engine, or GCVE. Oracle Cloud VMware Services, OCVS, right? And so this is, I call this the ubiquity between the clouds, right? So if you're going to have your on-prem, and we're fully agnostic to compute, storage, and networking hardware. And this is kind of the tenement about being portable. So let's say you establish a public cloud in a cloud provider A, doesn't really matter who, and you establish another public cloud presence in cloud provider B, or it could be the same cloud provider in two regions, right? For multi-regional, like out here in California, we've got wildfires, earthquakes, floods, you name it, and we've got some sort of natural disaster around it, except for the big hurricanes and whatnot. So it makes sense to distribute workloads or have some sort of DR between them. Basically, this is ubiquitous cloud. You can interlink all three in one way or another, and of course, makes the systems portable. But what if you didn't have vSAN on-prem, right? And maybe you had a second private cloud that also wasn't vSAN. So maybe you're running Pure Storage, or maybe you were in SimpliVity, right? Doesn't really matter to us. And what if you weren't running NSX on-prem, right? And you weren't running NSX at your second cloud site either. So again, it doesn't matter to us because the way we've structured our cloud offering, our multi-cloud or hybrid cloud, those workloads are portable between all those sites. And this is important because really vSphere is at the core part of what we operate in, right? We have ways of making the networking work. And of course, vSphere replication is inherent in all copies of vSphere. So storage platform doesn't really matter that much, but there's a benefit by having vSAN across the board. Again, we're fully agnostic compute, storage, and networking hardware. Any questions so far? And you're welcome to throw them in chat. I'm going to try to watch them. All right, so workload lift and shift. So you probably have already been approached by a major cloud provider. They say, hey, we don't care if you're running vSphere. We can take in your workloads. And this is technically called a lift and shift at the cloud, right? And so what they're offering to do is they're going to have their public native cloud A, again, doesn't matter the brand, and they've got their own compute storage and networking flavor that doesn't match ours. The problem with that is that when you move the workloads over there, that's technically a one-way journey. They're taking and moving it to a different storage platform from VMDK or VMFS or vSAN, right? And they're applying their own policies around networking, around compute, around storage that don't match up to what we do. Now, that seems okay, right? Because they're probably giving you a really pie in the sky price for doing that. But it eliminates the ability to move back seamlessly. So it's technically a one-way journey, right? There's also some huge things to consider when moving to the native cloud. So first and foremost, it's complete new security dynamic. So if you've got either regular traditional firewalls or NSX on-prem, and you move it out here, you now have to relearn everything and re-platform your network and security posture. There's zero legacy integration. So if you've had Cohesity or Veeam or something running, well, you now got to use native tools to do your backups. You now got to use native tools to do your load balancing, right? So it's a big, it's not just a lift and shift of the VMs, it's a lift and shift of your whole operating model out to the public cloud. We have no supported way to migrate those VMs back. So that means you'd have to rely upon a tool set. Some of these native cloud providers have tools that say, oh yeah, we can help you move it back. But anybody who's ever used, VMware Converter, right, doing a P2V, knows that's really last ditch effort, right? You don't use that for all your workloads. You use it as a, hey, this is, our only choice. And that would be the only choice that you'd want to use that tool set as well. Cloud native cost estimates are best case scenario. So I've had a lot of customers that have moved up into native cloud doing lift and shift. And their total, 150 VMs, which they were running on-prem for probably like a few $100s a month, cost them, $50,000, $60,000 a month to move out to the public cloud. This is because they didn't do any right sizing or alignment with, cloud technologies first. They just lift and shifted blindly up there. And then most organizations that shift cloud native make a move to return within a few years. There's a reason why every major cloud provider, Amazon, Microsoft, Oracle, IBM Cloud, even Rackspace, right? Why they leverage our tool sets versus doing their own native and pushing their own native now as a first choice is because the amount of boomerang customers is too high. So at least with this environment, if the customer does boomerang, they're not upset at the cloud provider for locking them into their technology. Instead, they're just, hey, this wasn't the right fit for us, maybe another day. So it becomes an easier conversation to absorb. And then you power this with HCX. So HCX is a cross-cloud acceleration tool. And here's a neat little quote from IHS Markit. So they migrated 1,000 plus workloads to support data center consolidation needs for corporate acquisition and to eliminate technical debt. So they had 2 environments that were as part of a corporate merge and takeover, and they were able to bring everything over without changing IPs, without replatforming, and it basically led to modernization of legacy workloads without refactoring applications. So they had old hardware at one of the companies they acquired. They brought it into newer hardware that they had running VCF platform, and it basically saved them hundreds of thousands of hours of people working, doing conversions, and or just copying the data, moving it by hand, and then reloading the data over there. So much more robust tool set. And I got 3 use cases set up here in slides that are common. So replication assisted vMotion. This is the one that IHS Markit used. And what we can do is we can take any legacy version of vSphere from 5, even though it's not supported. So please, hopefully you're not running 5X or whatever. And we can migrate them into 6.7 or 7.0. And we do this by extending out the layer 2, layer 3 networks using the HCX appliances. And then we do replication assisted vMotion. So what we're doing here is we're leveraging the inherent replication that's built into vSphere, deploying a replication appliance on both sides, a virtual appliance, right? So it's an OVA. And we can then copy the bits over in bulk, just like we're doing like DR. And then when the bits are there, we can actually bring that machine online in the new site. If something doesn't work properly, if it fails to come online, those bits are still available at the old site and they can just go back on, or it doesn't complete the transfer and doesn't skip a beat at the old site. So there's a lot of fail back and fail over options that make this a very safe choice, right? Mobility optimized networking. This is good if you're going to transfer, if you're not going to transfer everything at once, right? And you need to transfer, let's say you've got 2 VMs in the same VLAN and one's really large, a couple terabytes. So you just want to move that one by itself, but you can't really have downtime. Maybe you move it on a Sunday and then during the week, you've got 2 systems on the same VLAN across from each other. And then you want to move the rest of them later on in the week. So during that week time, you don't want any downtime or lost communication. Well, whether this is private to private cloud or going up into the actual cloud, like I described earlier in the hybrid cloud model, we can actually extend the network out. And what we do is we establish a BGP marriage between them. We can actually support OSPF now as well. And that's done at the host level. So the hosts will have independent network subnets. And then we encapsulate the VMs at the host level through a tunnel and then bring the network back over on-prem. And you can see the pattern here, right? We migrate the VMs, we inject the routes at the host level. The hosts do the layer 2, layer 3 calculation. We can then advertise the routes across the wire. And then we pull the routes back in over here on the left side where the other VMs are existing. And we can do this for several VLANs or several subnets at a time. So this gives you an opportunity to say, hey, I want to move, I've got 1,000 VMs and I want to move a couple hundred a weekend. This would be the way to do it without skipping a beat. Excuse me. And then SRM readiness. This is my favorite topic, is SRM and DR. My claim to fame when I was in the private sector was accelerating DR plans, leveraging SRM and native VMware tool sets. And I got really good at it. And what we do here with HCX is we basically use the replication assisted vMotion technology, which is both part of HCX and of course replication. And we can replicate more effectively across the wire between the 2 sites. We can also give you layer 2, layer 3 readiness for your DR plan. That way you don't have to change IPs. We all know, if anybody's done a DR plan, changing IPs is pretty much the enemy, right? You do that, and we all know that applications weren't prepared, DNS is not prepared right, things kind of, act funny. So you have to do a lot of TLC to do your DR plan properly. Well, with HCX going across a major site like this or up into the cloud, you eliminate that kind of problem. And you can go straight into just leaving the IP up, making sure that you've got your layer 2, layer 3 extensions running. You can replicate. And I've seen customers go from a DR plan that takes them 2 to 3 days to execute for about 400 VMs to getting and having their DR plan fully tested and vetted in about an hour and a half for 400 VMs. So you can do some pretty neat stuff with this. Any questions? I've got an environment here. I'm going to reshare. Let me reshare here. And this is our hands-on lab. And I picked this one because this is a really nice hands-on lab. It's what we call a guided walkthrough. It's not an actual test environment. It has the clicks kind of predestined for you. And it's with Azure VMware Services. And so we're just going to go ahead and click here, and we're going to create a disaster recovery solution. And it's going to accelerate with HCX. And so it deployed. It's obviously not that fast in real life, but this is a simulation, right? And now we're going to set up replication. And you can see that Azure has their own interface as I click through this. And what they're doing is they're just using APIs, no differently than what the Power CLI commandlets would use to do this. So we're going to go ahead and log in here. Set my password. And I'll give a link for this lab too. So we're going to create a site pair. Anybody who's done this knows that that it's once you've learned how to do SRM, it's not that hard from there on out. So you have to create the site pairing, accept the certificate, tell it which vCenters and SRM managements and replication are part of it. Again, accept certificates of each one. By the way, if you don't have DNS and NTP set up correctly when you establish SRM, you're going to have a bad time. I'm just going to say that right now. All right. And now I can start replicating workloads. And what's cool is it brings you the SRM interface automatically. It asks you to tell the target site. You want to double check that you have the right VMs in your target, right? Or for your target. You have to map the data stores between the two sites. In this case, they're vSAN, so it's pretty easy. We're going to use network compression to speed things up. We're not going to do a protection group just yet. And then we can manage the site pair. We can manage the networks. We're going to create a network mapping. And network mappings are just a way to, when you automatically choose a VM in a network segment or a subnet, the mapping is used to basically integrate that automatically. We're going to test the network. So test networks is really cool. If you've got a complicated DR plan and you're told that you have to audit your DR plan twice a year, the test networks allow you to do that, because with an SRM, when you initiate a test, it will bring the VMs up in the test network so they can't communicate back with production and ruin everything, right? So by having the test networks, you can test it in a bubble and let your auditors validate that everything came up properly. And then when you then you click the destroy environment, and it destroys all of the test stuff that was created, and then goes right back to replicating the way it was. And you can map folders. You don't have to, but it's definitely a way to, if you do organize by folder, it's helpful to do that. And it asks you if you automatically want a reverse map. It's pretty much the same thing, but just opposite direction. And then we're going to map the resources, which is technically the cluster, right? And we got to reverse map the cluster as well. You can actually map by host too. I don't know why you'd want to, but you can. And then this is the opposite recovery storage policy. There you go. And then placeholder data storage good for holding things. Say it holds the virtual machines before replication or before they stand up. Create that on both sides. Now we create a protection group. And protection group is a basically way to manage your actual failover. So if you have storage replication going on in the background, generally replication groups are going to be by data store, because that's how storage replication works. But if you're using vSAN or a vSphere replication or vSAN replication, then you can do the protection groups any way you want to. In this case, we're going to include everything that we created earlier. We're going to name a recovery plan, and we're going to complete it. Now, what you're going to find in the protection group and the recovery plan is that everything is automatically added to priority 3. You can see that right there, right? You can shift stuff around to higher priority groups, and they'll turn on sooner than these will. And you can also assign lower priority groups if you wanted to for them to come on last. So generally, you're going to have your databases come on first, or infrastructure systems like Active Directory. Hopefully, you're going to have Active Directory fully replicating all full time. Maybe you need your Java servers to come on second. So you can see all of your VMs are now in a priority group. So power on these first, these second, and these third. And then we can actually test it. And what this does is when you do a test, you could say, wait for the last set of change block tracking blocks to change, and then come over to the recovery site. Could add up to 15 minutes depending upon your bandwidth and your RPO, RTO. You can also uncheck that, right? And it will skip that step and just turn them on as is. So you can also do that during a DR event. So during a DR event, if you still have access to both sites, let's say you're being told there's a flood coming in, your data center is going to possibly be flooded in the next hour, you want to do a graceful shutdown and let it replicate the last bit of blocks if you can, right? But if you actually lose your data center due to a failure in the UPS and all your systems are down, you can't access them anyways, then you can go to the failover site and say, just go ahead and fail over. And you can see the, let's see here. So this is, I can't remember which site this is. This is New York, right? So we're going to go to the recovery site. We're going to clean up. So all those VMs were running as a test. What the cleanup does is it deletes the temporary environment that it established with the temporary networks. It deletes the Delta VMDKs and then tells replication to go back where it started. Now, if we want to run an actual failover, now, just a basic warning, anybody who's ever dealt with DR and you've done this for a little bit, you know that you do not fully automate your actual DR plan because the amount of false positives you're going to get are going to be pretty hair raising, right? You could have a semi-network outage between the sites, and the last thing you want is for your DR plan to stand up on one side and your global load balancers to start shifting everything over to your DR site on accident. So you never want to fully automate that, although you could use an API call to call up DR to actually activate it. Plan migration basically does the last bit of changes on the disks, and a disaster recovery just goes ahead and says, you know, nuclear option, we're going for it. There we go. And the VMs are stood up. See? It turned off the ones that we selected here on the main site. And then reprotect reverses the replication. So we've had a DR event. We failed over, in this case, just a couple select VMs. And we want to now say we've got change data on the DR site. We want to reverse that. So we're going to go and do a reprotect. We're going to click finish. That's going to actually reverse replication, bring back the data to the main site, and that's it. And then we're going to do, let's see, it's asking me to do it again. Oh yeah, we're going to reverse. So we reprotect, which reverses replication, and then we run the DR plan migration again to actually bring them on to the main site. You can see the DR site's all offline right now. And of course, we have to reprotect again. So there's a lot of steps here. So now these are placeholders. You can tell by the icon. These are what we call placeholder VMs. They can't be powered on except through SRM. And then they're all running on the main site. And then here's an audit of it. You can see the difference between a test, cleanup, recovery, reprotect, right? And then within here, we can create a report. And in the report, the auditors can see everything they need to see. All right, any questions?